Okay, number 8. So I'm going to let u be the inside, 1 minus x. So then du dx is equal to -1. And then when I rearrange that, dx would be equal to negative du. And then we're going to go ahead and do our substitution. So then I have the integral of 1 minus x is now u, so u to the power of 4, multiplied by dx is negative du. So I'm just going to put the negative out the front and deal with that constant right from the beginning. And I'm left integrating u to the 4th in terms of u. Remember that du is just a command. That's not a product. It's just a command saying, now let's integrate u to the power of 4 in terms of u. Good. My variables match. Perfect. Okay. So this is equal to negative u to the power of, add 1 to 4 is 5, divide by that new exponent 5, and add c. And then we just rewrite that in terms of x. U was 1 minus x to the power of 5 plus c. Done. Next one. Example. Oh, I gave myself lots of space. Example 9. Okay, so this one's got more going on. Let's see. Underneath the radical is where I'm going to find my u. So let u equal 1 minus 4x squared. So we're going to take the derivative of that. Du dx is equal to, the derivative of 1 is 0. The derivative of negative 4x squared is negative 8x. And then we will rearrange. So really what happens when we rearrange is we multiply the dx up and we put the negative 8x, we divide it down. Okay, that's really what's happening in the rearranging process. So we end up with dx is equal to du on negative 8x. And then we get to do our substitution part. So we still have an x up on the top. Okay, we didn't use a substitution for that. 1 minus 4x squared is our u, so we have the square root of u on the bottom. And then the dx part is our du on negative 8x. So here you can see where it's getting to be a little more complicated, and the beauty of the substitution rule. This will allow me to cancel out that extra x variable, and then everything that's left is either numbers or u, which is what we want, okay? Now that negative 1/8, just a constant, is going to go out in front of my integral, and then I'm going to write that u, the root of u, as u to the negative 1/2, and so then we're left integrating u to the negative 1/2 in terms of u. That's what the du is asking. Okay, so this is equal to negative 1/8. Now we're going to add 1. What color should I use? Add 1 to that fraction. So we get positive 1/2 divided by that 1/2. And maybe you would like to just kiss and flip that right away. And then we have r plus c. And then let's tidy this up. So negative 1/8 multiplied by 2, negative 1/8, maybe I'll write this one out this time, divided by 1/2, so multiply by 2 on 1. And then u was 1 minus 4x squared underneath the radical plus c. So then we have that negative 8 times 2 gives me negative 1/4. Root 1 minus 4x squared plus c. All right, number 10. So first of all, let u equal. So we're always looking to see where is the inside function. That's who our u is going to be. So in this case, it's in the brackets. So x squared minus 4 du dx. So the derivative of that is 2x. And then when we rearrange, essentially the dx and the 2x switch spots. So I have dx is equal to du on 2x, and then I'm going to do my substitution. Okay, so let's just move this up a little bit so I can see again. So little f of x was given to me. So I might write big f of x is going to equal to the integral of, I still have my 2x, and then the inside brackets, that's my u to the power of 3. And then I normally have a dx here, is being replaced with du on 2x. So if you think about what this would have looked like with its symbols, this would have had an integral symbol out the front, and it would have said in terms of x. So that dx command would have been out the end. And then what we see here is those 2x's get to go away, and we're left with integrating in terms of u. Okay, now I'm left integrating in terms of u to get to my function. So add 1, you get u to the 4, divide by that exponent, plus c. And what was u? Pardon me. So now I'm going to say big f of x is equal to 1/4, and u was x squared minus 4. And that would be to the power of 4 plus c. Awesome. All right, number 11. Again, if you haven't tried any of these on your own yet, then I would encourage you to actually press pause on the video now and give number 11 a try. Okay, let u equal. This time it's underneath the radical, 5x cubed minus 2. Then the derivative, du dx, is equal to 15x squared. Rearrange that. So you're going to have dx is equal to du on 15x squared. Secondly, we're going to do our substitution. So we're going to substitute under the radical. So the x squared stays, and then the is going to be the root of u, and we replace the dx with du on 15x squared. Now in this case, the x squared cancels, but I still have this 15 left over. Now again, as long as it's just a number, that's okay. He just gets to go out the front. So I have 1/15, integrate u to the power of half in terms of u. And then we go through our process. So this is 1 on 15, u to the power of, add 1 to a half, you get 3/2, divided by 3/2, or maybe it's better to just write multiply by 2/3, depending on your comfort level. This is the same as multiplying by 2/3. And then we're going to get, when we multiply the 2/3 and the 1/15, we get 2 on 45. And my u was 5x cubed minus 2 to the power of 3/2 plus c. Fantastic. Hopefully you were able to do that one on your own. Number 12 and number 13 come from chapter 8. So we're going to bypass those ones for now. And I might come back and do them at the end of the video for those who are interested. And we're going to move towards trig. Okay, so number 14, we actually don't need the substitution for this one. I could just separate this out. I could do the integral of 6x squared plus the integral of cosecant squared x. Then I need to say in terms of dx on each of those. Okay, so I could just use that property, and we know how to integrate 6x squared. That was like example 1 at the beginning. So this would just be 6x cubed on 3. We'll hold off the plus c till the very end. And then what is the antiderivative of cosecant squared. So that was on our little general antiderivative chart. I think it's also on your formula sheet, and it would be negative cotan x. So if you think about whose the derivative has cosecant, it's cotan, but it would be negative, so you have to switch your sign. And then we just put a plus c on the end. Okay, so if you had a plus 5 on the first one and a plus 7 on the next one, you have a constant, plus 12. So we just make it one big c at the end. And then what could we do to tidy this up? 6/3 is 2x cubed minus cotan x plus c. And that's it. So this trig guy, we don't often use the substitution rule on. We just use our little rule from the beginning that we looked at, okay? So this actually allows us to bypass, okay? So if we have an argument with a coefficient, we just have to remember to put the 1 on k in the front. And then don't forget your plus c, okay? So the antiderivative of cos would be sine, and the antiderivative of sine would be negative cos with the correct k elements. All right, so go ahead and try 15 on your own because this is very similar to what we did in example 2. So we would have that f of x is equal to 5 times what is the antiderivative of sine. It is negative cos of my same argument multiplied by 1 on that k value, so 1 on 3. And then this would tidy up to negative 5/3 cos 3x. And then don't forget your plus c on the end. Now we could have used let u equal 3x, but we have this little rule that allows us to bypass that. I mean, you'd get to the same conclusion if you did that. Okay, example 16. Again, we could let u equal x plus 3, but we're not going to need to do it because the exponent on the x is 1. So we don't need to do it. So as long as that exponent on x is 1, we don't need to use the substitution rule with this trig function. So I'm just going to call it big F of x would be equal to, remember that negative 5 can very easily be written in front of my integral sign, okay? So I have negative 5, and then what is the antiderivative of cos? It is sine of the same argument divided by whatever the coefficient of the x is, which happens to just be 1, so we don't need to write it, plus c. So what is that? Negative 5 sine x plus 3 plus c. All right, so we're going to look at a little more complicated trig one. So those two allowed us to bypass. I just realized I missed a bracket on here. Sorry. There we go. Allows us to bypass the substitution rule. But what happens if we have something a little bit more complicated? So we have a sine x multiplied by a cos x. So we have a product here. How are we going to do this? It's going to need us to do the substitution rule on this. Now remember, the substitution rule allows us to undo the chain rule. We are not undoing the product rule here, even though it's written and presented as a product. We had other products that we were undoing, 2x times something in brackets to the power of something, right? That was a product. And so just keep that in mind, that this method of integration, and we're going to learn some other rules in chapter 11, but this particular method, the substitution rule, allows us to undo the chain rule, okay? So I like you just to think about this. How many different ways can we do this question? And I'm going to come back and look at it in the next video with you.